Hey everyone, welcome to my tutorial on normal maps and cleaning up your 3D models in Maya. I thought I would do this in video form because there's quite a few steps and there's also a bit of nuance to go through too. But this can be really useful for cleaning up your 3D models that you've kind of done yourself, where you might have created some accidental non-manifold geometry or some bad geo that you need to clean up and get rid of from your scene. But I also want to show you how to take the detail from something that's quite high res and bake it down into something low res that we can actually use in a game engine like Unity, where we need to hit certain try or polygon count budgets. So I'm going to start off with one of the scans that we've done in class. If we start with this model, you can see there's quite a lot of detail and little pock marks all over it, kind of edges in here. The face, we didn't capture a huge amount of detail on the face, but there's enough there that you would want that represented in your scene. But the main issue we've got is that we're at sort of almost 70,000 triangles. Now, if you were working in a platform such as Oculus, Quest, your try budget's going to be about 500,000 in one scene. So you imagine you've got 5 of these, you're already almost at your entire budget for the whole scene. So especially when we're designing for mobile chips and processors, we have to keep our try counts really efficient, but we do want to keep this sort of level of detail that we've got here. And how we need to go about doing that is by a process called normal map baking. Okay, so first off, not everyone will know what a normal is, and I hope to dispel that a little bit here. But what a normal is essentially the light direction of every single face on our object. And you can actually look at your normals in Maya by coming down to display polygons and looking at your face normals. Now this is going to look like a bunch of sort of hairs have appeared over our model, but you can see each one of these 2D lines is in the center of our face and it's pointing off at a different direction. And what that is our engine's understanding of where that object is facing in a world space, and that lets our engine calculate how to light our model correctly. So with a high detailed model, we've got heaps of normal information to work with, so that means we can light our model really accurately and show off a lot of the detail and the geometry. But with something a lot lower geo, we're going to lose a lot of that information, and so we're not going to be able to show off the lighting detail and the depth that we've captured. So what we need to do is actually bake all of that information into a texture. So each pixel of our normal map can tell our scene where each face is going to be oriented. So we can sort of calculate the lighting based on the texture that we've applied over our geometry. And I'll show you one of the normal maps I just baked before as a test. So you can see this one. So we've got RGB values, and essentially the red, green, and blue, each channel is saying the X, Y, or Z orientation of the face that it's assigned to in the UV. So if we want to bake this one down into a lower resolution mesh and capture the detail, the first thing we need to do is remove some of the bad geo and clean up our mesh so we've got something nice to work with. So I'm already anticipating 2 problems when looking at this model. One is there's a little bit of noise here, which has just come from our laser scanning, so we'll need to remove that. And 2, we've got this sort of weird tail end area of our model, and I don't think I'm going to want that in my final output, and it's going to be unnecessary geometry taking up resolution in our game engine. So what I'm going to do is remove this one and delete this area and patch it up. So first off, I'm going to click on my model and I'm going to go under our mesh and I'm going to choose the separate operation. And what that's going to do is pull out every single mesh shell, and by mesh shell I mean a mesh that's enclosed. So we can have a mesh that's the whole head, but we might have multiple enclosed areas within that object. And so this is one here. So now these have all been separated out and I can actually go through them here in the outliner. Some objects you might have a whole host of these where you've got lots of different noise going on. And so you might want to just remove the ones that you're not actually wanting in your final model, and we can only apply this technique to one mesh at a time. So if you did have separate parts that you've combined together and you want to run this on all of those parts, you're going to have to separate them out and do it one by one. But since I don't want this, I'm going to delete it, and I don't want it in this sort of group, so I'm going to remove the parent by going edit and unparent, and I'm just going to delete that original. Because I deleted that original, I've now lost all the surface material shader information of that. So I just need to select my object and assign a new material again. So we're back to where we were. The next problem area to tackle is this funny bit of geo down here. And there's not really an easy way to clean this up other than doing it manually. So what I'm going to do is go into face mode and just select maybe this amount of geo. So yeah, that looks pretty good. Maybe a little bit less. I might take it from this side. So that looks pretty good to me. So I'm going to remove this part. And then I'm going to patch it up. So I'm just going to, yep, happy with that. I'm going to hit delete. And then I'm going to reselect these edges and then use the mesh fill hole. Now I've got a lovely n-gon here, which we don't want. So I'm going to triangulate that one. So now it's been broken up into triangles. So that hole is now a little bit healthier. And then I also need to smooth that out a bit again because I just want a little bit more geometry there. So that's a little bit better. We do have a bit of funny edges, but for the purposes of this, that's a bit better. I'm not going to worry too much about it. All right. So heading back into object mode now, I've got a good form here and I don't have extra shells. The next thing I need to do is clean up my model and remove any invisible non-manifold geometry. And non-manifold geometry is essentially an say a vertex where, an edge, where you, instead of having, say, two faces coming off it, you've got like a third inner face coming out in Z space. And, you know, that might not be a visual problem for our model. We might not see it because often these will be inside. But it is going to affect our ability to run operations on it. And it's going to be bad for our performance in Engine because we're going to be trying to render faces that are sort of interior. So I'm going to run a cleanup. And so I'm going to select my object and press the little box next to cleanup here so I can expand the options. And there's a few things I want to ensure I've ticked. So it is quite tempting to choose select matching polygons so you can see where the non-manifold is and then delete it. But that will actually only run this operation once. And that means I'm going to have to keep doing it, pressing select, delete, select, delete. If I just choose cleanup here, it's going to keep running this until all of the manifold geometry is deleted. And why you have to run it multiple times is sometimes this operation can actually create non-manifold geometry. So it ends up needing to kind of recur over and over until the issue is rectified fully. So I'm going to select cleanup up here, apply to the selected object only, so I don't want my whole scene if I had other things going on in here. Now we get a few options here. So fix by tessellation means these are fixes that are going to be similar to how I triangulated that hole before. We'll break up an n-gon into multiple pieces. And we could do that for four-sided faces if we wanted to triangulate a quad mesh. Our n-gons, so more than four sides. Any concave faces, because we know in Unity concave faces can be trouble for physics calculations. Faces with holes, non-planar faces. I'm not too worried about these. So I'm gonna, these three, I'm gonna leave these two ticked so I can eliminate those issues. I also want to remove laminar faces and non-manifold geometry, and we're gonna apply that to the normals and geometry. But essentially this is the most important thing to have selected, because this is what's going to affect your remeshing and retopologizing of your object. So let's apply that one, and we'll give that a sec. Usually it is quite a fast operation, and I'm just going to click that twice to make sure that worked. So now we should have a nice clean mesh. Sometimes it won't do anything, and that just means that we didn't have non-manifold geometry in the first place, so our mesh was already clean. Great, so we're almost ready to bake our mesh. What we need to actually do now is create our source and our target. So our high poly one, which is sitting at 68,000, is going to be our source mesh. So it's going to be the source of our lighting information. And we need to duplicate that and create a target for our lighting information. So I'm just going to rename these ones. So we're going to have a source. Actually, let's go with high poly and low poly. And that's just to make it a bit easier for us to understand. So now we've got two of these and they're sitting in the same position. Actually, before I do that, I'm going to fix this access point because I'm not very happy with that. You just press D to unlock your pivot control and then D to lock it in again. All right, let's duplicate that again. Rename this one low poly. Great. So the next step is to actually retopologize our mesh. And what that means is we're going to reduce the amount. It doesn't have to necessarily be reduction as well. You can retopologize to a higher res, which is often done when we're going to do a sculpt or something like that. But a retopologization essentially will reduce the amount of polygons in our mesh, but it's going to focus on areas where we're going to need a bit more resolution, I guess, in our mesh. So up here on the head, already we don't have much, but let's, for example, this area, it's quite high res and we probably don't need as much resolution here as we do around, say, the ears and the face, because that's where sort of the hard edges are. So I'm going to snap these back and select my low poly face, and we're going to retopologize that one and focus on the areas where we need a bit more detail. So I'm going to just select this little checkbox here again to bring up our options. I'm going to set this as having a target face count of 7,000. Now you'll notice we almost always overshoot this, and that's okay. So this is just nice to give Maya a bit of a target of like, I want this much resolution. It'll probably give us 10,000, but if I put in 10,000 here, it'll probably give us 15. So always leave a little wiggle room in there, and that comes from this tolerance as well. So how much you're happy for it to overshoot or undershoot. And I think it's best practice to give it a bit of space. And if we were using something that was a non-organic model, so something that had hard edges or surfaces like a box or I don't know, a piece of machinery, we might want to choose preserve hard edges up here. But because we've got a nice head, which is organic, it doesn't really have hard edges, I'm going to leave that unticked. And so we should be ready now to apply that. And you can see we're retopologizing here. And that might take a few minutes. I've got a pretty good CPU and it takes me, I don't know, a good minute or two for a medium resolution mesh, something with about 150,000 to 500,000 polygons, it's going to take even longer. So just keep that in mind. It may not have frozen, it might just be taking a few minutes. All right, so after about a minute or two, we've got our nice new mesh, and you can see there's quite a difference. So this one's much smoother, so we've lost a lot of this nice clay details and lumps in the head. But we've got, the main areas of geometry nice and preserved. And that just goes to show how good the Retopology tool in Maya is now. So this didn't exist before 2020 version, and we had to work with the reduction method, which left a lot of jagged edges. So this has created quite a lot of nice geometry for us. So we've got little areas of higher resolution around the face and the nose, the ears, back here around the neck. Sorry about that, I actually had a bit of a Maya crash, and that was because I tried to go onto the UV mapping and skipped a step. So I'm back to having my high poly and low poly, but I haven't done my retopologizing yet. I'm just going to save in case I have another crash. All right, so I've got my low poly, and I'm going to again run my retopologize and give it a 7,000 target. All right, so our retopologization function has done, and we've got that nice lovely geometry again. What I need to do now is actually bake that retopologization into the mesh by deleting the history. Now the reason I want to do that is because anytime I try and run another operation on this mesh, it's actually going to try and run that prior to my retopologization in the execution order, and then try and do the retopologization again. So I'm going to end up wasting a lot of time and sitting here while that goes over and over again. So what I'm going to do is just freeze what I just did to that mesh into it by going edit and deleting by type history. So I'm going to delete all of the changes in the history, and you can see now we just lost a bunch of info there, but we don't need that. We've already got a backup copy anyway. So now we can add our UVs again. So for the high poly, I can just stick with whatever automatic UV, and you can create a new one by going create automatic, because this actually doesn't matter. It doesn't use the UV of the source mesh, it uses sampling in Maya itself. But for our low poly target, we do want to give it a somewhat nice UV, and that's because that's going to actually dictate where our texture gets placed, and it's going to be on the model that we export out of Maya into Unity or whatever destination we're taking it. So I'm going to create a spherical UV, because basically my head here is essentially a sphere, and that will leave our seams at the bottom and the top, which for the purposes of this I'm pretty happy with. If this was your own hero model, you might want to actually properly UV it out at this point, but I'm going to go with a spherical, and that's given me a pretty good result. So I'm just going to adjust it so I can fit everything in, and we'll leave a seam there. Oh, down the back, so that's all right. That's probably where we would have to place it regardless. And let's just get the entire model in here. Great. And what I'm going to do is squeeze this down a little bit just to make sure 100% of my map is in, and I'm going to select these funny looking faces out here and just spin them around so we're fully mapped. Again, this is not a great way to do this, but for the purposes of just the lighting, we can probably get away with it. Alright, So I'm reasonably happy with that. I can see I've got most of the face protected here in the middle, and then we're going to have a bit of funkiness on the outside, but a lot of that's probably to do with me not doing the most careful job patching up that hole there. So what we're going to do now is save again and prepare these for our bake. So I can go over to my rendering tab at the top here. So instead of modeling, we'll switch to rendering mode. And I'm going to open up my transfer maps operation under lighting and baking. And so we're going to get a bunch of options here, and I'll just explain a few of these. And let me just reset everything. Great. So our transfer maps operation is going to take a source mesh, which is going to be the source of all the information, and also a target mesh, which is going to be what we're projecting all this information onto. So obviously our source mesh is going to be our high poly, because that's got all the detail and the information in it, and our target is going to be a low poly. And now you'll see this search envelope option appear, but we can't really tell what that's doing. So what we need to do is change our display to both. So this is going to show both our mesh of our target and the search envelope. And the search envelope is like a balloon that wraps around our mesh, and it basically is the area where we're going to look for detail in our source mesh. So all we need to do is make sure that one, our source low and high poly are aligned, so they're in the exact same position, and that our envelope is big enough to cover our source mesh. And sometimes, your geometry will change a little bit because of your retopologization. So you might have things go a little bit out of the zone. So you just need to make sure your search envelope is big enough to cover everything. Now we come down to our next option, which is the output maps. And there's a few different types we could export here. So we could export a diffuse, which is like the color information. So if it applied some colors and we wanted to spit that out into a texture, I could do that here. We could also export a normal map and a displacement map, and those have two kind of different functions. So a normal will tell us the direction of all the faces and how they should be lit. A displacement will actually kind of fake the geometry being pushed out of the surface, and these are often used in tandem. A normal map is more for your detail, and a displacement is for like larger deformation in the surface. So if I was doing a rock, I would make all of the little holes, pockmarks, cracks, sharp edges a normal map. But then if I had large things jutting out, that would be a displacement. And that's kind of shown in this representation here. But for this, we're going to just choose a normal map. And I'm going to put it somewhere and give it a name. And that name is going to be head normal shoot, and I'm going to make it a PNG, and that's kind of up to you, but find PNGs, just a overall safe format to use. So I'm going to save that there, and you'll notice if I've got PNG selected here, now it should update here to say PNG as well, but just make sure that whatever's here matches here as well. So for our map space, we're going to leave that as a tangent space, and that's sort of the type of normal map we're going to get. But Unity and most 3D apps by default will read a tangent normal map, not an object normal map. In terms of our connected maps, we're going to make sure our map connects to our assign shader, so the one we've given it already. And just to make sure, because I'm not sure if I did it between the crashes already, I'm going to assign our low poly head its own texture. So I'm going to just go assign a new material and give it another standard surface. And that's just to make sure that when we're choosing assign shader here, it's going to get applied to our low poly, not our high poly. Great. Now the next section is the my comment output, and this will actually, it should persist between your projects, but just make sure you've got enough resolution on your map. So by default, mine gives you 256 pixels width and height, but it's not really enough for a modern normal map. We're going to go with a 1K texture for this purpose, but if it was your character, you might go as high as 4K. It really depends on how much detail you need. Now the filter size is essentially how many samples we're going to take of our high poly surface. So how many of those normals and in what level of detail am I going to pick up and apply in the normal map? And often if you choose the default filter size, you're going to find that your detail gets kind of blurred a little bit and exaggerated. So even though on my base mesh I've just got a little bit of darkness under the nose, then it'll actually give us a lot of darkness around this much, because it's kind of blurring the data we've picked up. So I usually change this down to either 1 or 3, and I would really only change it off 1 if I was getting too much noise or it was taking forever. But you'll have to kind of experiment with that value a little bit to get the desired effect. But the sampling quality I'm happy with being medium. Advanced options I never touch. Just make sure delete envelope on bake is selected so that it removes that unnecessary balloon around your object when we actually export it out. Alright, so now we're all set up and ready to go. I'm going to hit bake. So now it's done, but if we actually move this over, we don't see any change, and that's because I haven't pressed the magic button yet, which is 6 to turn on our texture view. So if I press 6, now I've got my normal map applied, and I think the effect was quite successful. So we've been able to pick up a lot of this little detail and the bumps and crevices here. The face is looking much better, and I can press 5 and 6 to flip back and forth between them. You can see what I was talking about with the filter size. So even on the smallest filter, it's exaggerated the lighting a little bit down here. But I think that effect is totally fine, and it will look a bit different in engine as well, and depending on what material you give it. Now you do get a bit of funkiness around the seams of our UV, so at the top of the head you can see there's a little bit of patchiness going on, but we've done a pretty good job of protecting that along the rest of the seam down the head, and then we do see its surface again at the bottom of the model where all the spherical points of our UV meet, but our actual main face area has been really well protected, so we've got a lot of good detail happening there. And you can check your export folder. You should have now gotten, oh, that's the wrong one, a lovely UV map, and we can almost zoom in here and see the face shape there. So here's the eyes, nose, and ears. But of course, every RGB pixel in our normal map is now representing the orientation of each face on our low poly model. And if I go and display there, no, I want heads up display poly count. As you can see, we've reduced our object down to 14,000 triangles where we did have 68,000. So we've kind of quartered our resolution in geometry while keeping majority of the detail there. So I think that's been quite effective, and what I might do now is export that one out of Maya and just show you what that looks like and how to set it up in Unity. Alright, great, so I'm back in my sort of test scene that I've got running here. What I'll do is import both the mesh and texture into Unity here, and for some reason my Unity doesn't want me to import by dragging, so I'm going to go to my desktop and select these two. Great. Now let's just drop it in the scene, and often if you've exported from Maya in the same folder and name as our normal map, this should have actually picked up our normal map already, and let's see if that's the case. I want this bigger, so I'm going to increase the base scale import by 10, so 10 times that. Ooh, it looks like it hasn't, which is totally fine, because that means we get to do it ourselves. So I'm going to export the material that came with our object, because you can see I've got a material here. And so I'm going to select extract materials on the import setting of my mesh and just drop them in the same folder here. Now I've got the material that's already pre-assigned with the same UVs and such as my mesh. And I can drag my normal map into the normal map slot, and you'll see it's already come up with a warning saying, hey, the texture you just imported hasn't been marked as a normal map, and that's because it hasn't here. So it's a default image, but you can just use the little fix now pop up here to rectify that, and you can see that that detail has now come in. And we might want to change the color of this because it's a bit bright and blowing out in our scene. Alright, and there you go. You can see I've set up a bit of a sort of bronze looking material here, but our normal map is imported and it's also applying on all of our reflections, so we're getting nice areas of reflection in there as well. So if I turn off my smoothness, you can see that, and if I turn down my normal map, we go from the basic geo reflection to a bit of a higher res reflection. Thanks everyone, I hope you've learned a bit about normal map baking and how to clean up your meshes, and just in general what normals are and what sort of process you might use. I hope to see some of you using this technique on your models, especially to add in little bits of detail without, destroying your target polygon amount. But yeah, thanks so much.